You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone, and thanks for being here today. I'm Kirk Mona, and joining me are Rachel Gimza and Victoria Thompson. We're all naturalists who together have scoured the world for weird and wonderful wonders, just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Well, hello, everybody. Welcome to the show. So good to see you guys as always.
Hey, good to be here.
Love it.
I get to start things off this week. And, you know, I did an episode the other week about the world's deepest cave, you remember?
Mm-hmm.
And
Indeed,
afterwards, I realized...
Kind of hard to forget.
Yeah, very deep. But I realized that we had never talked on the show about the world's deepest place, the Mariana Trench.
No!
Yeah,
No!
very true.
Oh, no!
I get the feeling this is something Rachel wanted to talk about at some point.
It's always lingering in the back of your head. It's always
waiting.
there,
Yeah.
ready.
Well, Rachel, in all fairness, you had 5 years to get around to it.
I
So.
did. As
Snooze, you
well,
lose.
I did lose. Oh, keep going. It's so good.
At least you hadn't prepared it for this episode.
No, I did not.
Okay, good.
I did.
Well, for those who don't know, the Mariana Trench lies in the Pacific Ocean. It's to the east of Guam and the Mariana Islands, which make a curve from the north to the southeast. And the whole trench is about 2,550 kilometers long. That's 1,580 miles. And the average width is only 69 kilometers, or 43 miles wide.
Wow.
So,
All right.
by comparison, the Grand Canyon is 446 kilometers long and averages 16 kilometers wide. So, the Mariana Trench is considerably narrower relative to its length than the Grand Canyon.
Okay.
Huh.
Interesting.
Okay.
Relative to its length. Okay. All right. I got you.
Also, its depth, I think.
Yeah.
But I mean, it's actually wider than the Grand Canyon, but
It is.
relatively speaking. Okay.
Yes.
Mm-hmm.
Had to wrap my head around that one.
So the trench is there because it's in a subduction zone. That's where one tectonic plate is thrust down under another plate. In this case, the Pacific plate, really big plate to the east, is going under the much smaller Mariana plate to the west.
Right.
Oh, okay.
I'm
And
glad
the
that it has its own plate name. That feels very fitting.
Yeah, it's just like a
Just
little crescent
Must
of
be a
thing.
little one though, right?
It's
Yeah.
very
Mhm.
little. Yeah.
Beautiful.
The Pacific plate is actually the largest plate that does not have a continental landmass on it, which is kind of interesting.
Yeah.
Well, there
Never
are
really thought
rocks
about
on.
that.
Oh, sorry. Go ahead.
No, I just said I had never really thought about that.
Yeah. Well, there are rocks on continents that are more than 4 billion years old. Ocean crust is all considerably younger because it's constantly being recycled by plate tectonics. But some of the oldest ocean crust rocks, which are about 190 million years old from the Jurassic, are found at the western edge of the Pacific plate,
Very cool.
where it is going into the Mariana Trench. And the older ocean crust rocks get, the denser and colder they are. So that's one of the reasons that the trench is so deep, is because it's like sinking farther than usual, I believe.
Oh, interesting. Okay.
I read that. I wasn't totally able to verify that little tidbit of information,
Yeah.
but it made sense. So hopefully that's correct.
Yeah.
So we hope it's true. Okay.
Yes. Okay. But the question we're all wondering is just how deep is it, right?
How deep is it, Victoria?
Okay.
We have to know.
Well, of course, the trench overall is quite deep, but there is a deepest spot, and that is known as the Challenger Deep. It is
Yeah.
just a hair under 11,000 meters, a little over 36,000 feet. Just for a little perspective, Mount Everest is 8,848 meters high above sea level, or that's 29,031 feet. So the trench is, more than 2 kilometers deeper than Everest is tall.
So
above
you
sea
could
level.
say that it is the Everest of ocean trenches.
Indeed.
No, in the fact that it's like
I know you
like
hate
the
that.
inverse of Everest.
There's a kind of
you're
cool
overthinking it.
infographic that I saw when I was doing the research for this article that showed it had them sort of side by side, Everest going up and the trench going down, and then it showed, like where's the Burj Khalifa and Denver,
where do airplanes fly? Yeah.
Where airplanes fly, exactly, yes. And thousands of people have summited Mount Everest, but the number of people that have reached Challenger Deep is 27.
Oh, wow. The last, more than I thought.
More than I thought too. Last crewed descent was in crewed. That means like with a crew.
Right.
Not a
people say
descent.
manned. I don't like to say manned.
Mm-hmm.
Yeah.
That's fair.
It was in 2022. The difficulty in exploring the deep ocean is high. And due in large part to the crushing hydrostatic pressures at those depths.
Yeah.
Challenger Deep, the water pressure is 703 kilograms per square meter, 8 tons per square inch. What does that mean? That doesn't mean anything to me.
Wait,
it's more than
tons per square inch, did you say?
Yes.
Oh my God.
Okay.
Over 1,000
so
times. Over 1,000 times the pressure at sea level.
Oh.
So
It's
any surface creature transported to such a depth would just be instantly squished into jelly.
We are pancakes.
Yeah.
At that this is why so like I'm going to interject here just a little bit. This is why like when people look at like the blobfish, which I know we haven't talked about on this podcast, but the reason why it looks blobby is because it's at surface level pressure. It's not at the depth of ocean that it's at, where it's supposed to be, where it looks like a pretty much normal fish.
Yeah.
It looks normal. It doesn't look very strange, just when it's at a different... Picture that, but different. If we go down there, we become the blobfish.
Right. And very dead, obviously.
I mean, opposite of the blobfish, but yeah.
Well, yeah, if we go down there, we become the blobfish rather than... We get squishified versus they get squishified at lesser pressure.
They get
We're the inverse.
Yeah, that's what I'm saying.
We're the inverse blobfish.
Yeah.
Yeah.
Of course, it's also completely dark down there and just about 1 or 2 degrees above freezing. So pretty unpleasant. Any exploration, needless to say, has to take place in specially built, exhaustively tested submersibles that can withstand this kind of pressure.
Well, the testing part is important.
Yeah. The first descent was a little surprisingly early for me. It was 1960. 2 men went down. A U.S. Navy lieutenant.
That is earlier than I thought it would be.
Yeah.
Yeah.
This submersible was built by a Swiss father-son engineer team, and the son and this U.S. Navy lieutenant were the 2 guys who got to go down.
It seems like you said that awful casual. Like when someone's like, "Oh, who built this amazing pressure vessel that is going to do this thing for the first time?" "Oh, this father and son threw it together for me." Nope. No. That sounds like they made it in their garage. I'm sure that's you undersold it, but that sounded so casual. Like, "Oh, my neighbor built it in his garage. I'm sure it's fine."
But Kirk, they were Swiss.
They were Swiss.
And it's the 60s.
It had incredible clockwork mechanisms.
Yes. The Swiss are known for being precise and
true.
All business.
I would be more like, it's the 60s. Why not? Could be fun.
Yeah.
I mean, I know a guy who built a plane, so like...
Wow.
In the 60s?
No, like, he's built multiple in the last couple decades.
Okay.
Okay. Good story.
Thanks. People just do things sometimes. They fly. His planes fly. Sure, why not build a submersible in your garage or whatever?
Yeah. Oh, you have
Probably
some chance of surviving
Challenger
a plane
Deep
crash.
is trying to kill you at all times.
Right.
At any rate, nobody went back to the Challenger Deep from 1960 to 2012, which is when the film director James Cameron went.
Of course he did.
Solo. Yes, that's his shtick now.
Solo. Okay. Why not?
Since 2012, there have been 5 other descents with crews. and a few descents by remotely operated vehicles. But like you might think, oh, it's better to send a robot down, but it's actually very logistically difficult to communicate with a robot at the bottom of the Challenger Deep.
That does not surprise me.
So just what is down there? Well, there's life.
Yeah.
Nice.
There's so much life. Well,
There's some. There's a bit.
There's an amount of life.
Yes. During the first descent in 1960, the team was not able to get any photographs or video because this huge cloud of sediment got stirred up when they landed. However, the men did see some small creatures sort of floating by in the cloud. And they claim to have seen a flatfish similar to a flounder.
Ooh.
And
Okay.
they had a very elaborate description of its eyes looking at them and it swimming away. I guess
Fun.
current later scientists are skeptical that they actually saw a flatfish. They think they might have seen a sea cucumber and gotten turned around. But
Okay.
there have been several other types of animals found and other life forms. So they've found shrimp, sea cucumber, scale worm, polychaete worm, and then in sediment samples they found lots of soft-shelled foraminifera, which are single-celled protists. Many foraminifera from shallower parts of the ocean have a hard shell made of calcium carbonate, like like an oyster or whatever.
Right.
But smaller, obviously. But at these extreme pressures, calcium is so soluble in water that any shell basically dissolves.
Oh.
So they can't have
That's
those.
not good.
They can't have those
No.
down there.
No. That's a no.
They have not found any vertebrates. So that's one reason they're skeptical of this flatfish story. And I guess they're also wondering, how would bones do down there? I mean, it's not in direct contact with the water. The bones wouldn't be, so I don't see the bones dissolving.
Pressure would still be an issue, though, with bones, right?
You would think.
Bones only can take so much pressure. How dense would they have to be?
Yeah. But, the truth is we know very little about the biology of creatures from this deep.
Fair enough.
As you mentioned, Rachel, it's hard to get an idea of what they look like really well, because if you bring them up to the surface, they get blobby or explode or variously misshapen.
Die.
You can
Bad
capture
things
them
happen.
in pressurized traps and then transfer them to a pressurized tank, but they have to survive the transfer process.
Yeah.
And that, they're able to do that with some stuff, but it's not so easy. First you have to get there, then you have to find the creature, then you have to get it to survive and do whatever experiments or observations you want to do. So, it's the bottom of the ocean floor is a bigger mystery than pretty much any place on the planet. It's really amazing.
So
Exactly.
cool.
It's so cool. There's so many things to find.
Yeah. Unfortunately, there's also pollution down there. They found plastic and stuff in the Mariana Trench. Plastic bags.
That's so disappointing.
Yeah.
Just can't get away from it.
I guess they were also talking at one point is would this be a good place to dispose of nuclear waste? Because it'll get subducted. Well,
That feels
man.
short-sighted.
maybe not.
It
actually feels long-sighted. I mean, it's going to take a long time for it to get subducted.
Yeah.
Well, yeah, but would it be broken down enough where it wouldn't cause problems if it got subducted?
Well, I mean, there's radiation
What's
in
it
the
gonna-
mantle anyway.
Yeah, there's tons of radioactive material in the mantle.
It's more like what happens before it actually gets subducted, or if it'll actually go down.
Yeah.
And
That's the bigger issue.
there's earthquakes and stuff. You don't know what's going to happen.
It just feels like a not great idea.
Yeah. Anyway, it didn't seem like there's any recent effort to try to do that, so we have that to be thankful for.
Well,
right.
Rachel, when you decide to go, that'll be, I mean, we could record a podcast from down there. No one's ever recorded a podcast from the bottom of Challenger Deep.
You could be the first.
That's true. I could be the first. I will. I raise you. How about instead I go to a Mariana's Trench concert and record the podcast there?
Oh, is there
The
a
sound
band
quality-
called Mariana's Trench?
There is a band. It's a punk rock band.
I'm gonna guess it's gonna be too loud.
Yeah.
I mean, not
100%.
sounds like fun, but like you probably get a higher quality recording. So I'm gonna have to,
Okay.
we
Or
can go to the
you-
concert and then you can go.
Third idea.
Okay.
Just
Then I
go
go
to
to the.
go to Guam, near the Mariana
Okay.
Trench, and record from there.
Ooh,
Maybe.
sounds even better. I'll even.
All right.
We can all go to Guam. How about that? We go there for the birds and the other animals, and we're really close to Mariana's Trench.
I like
If
that
we
idea.
get
Hmm
3,000 more patrons on Patreon.com, we will record from Guam.
There we go. We'll take a vacation and go to Guam.
Sounds
fun.
good.
That's what I got on the Mariana Trench and the Challenger Deep. I just
Amazing.
Cool.
thought, we haven't talked about that, and we need to talk about that.
Oh,
My
Thanks,
sources
Victoria.
this week, I didn't actually write them down yet, but I got something from the Smithsonian, got something from National Geographic, Fish and Wildlife Service, and the Earth Observatory of Singapore had some useful information about the age of the ocean floor. And then, of course, I got some background information from Wikipedia.
oh, beautiful. Thank you so much.
Thanks.
We are going to take a little break, and when we come back, Kirk will have something for us.
Hey everyone, welcome back. I have an interesting question for the both of you.
Oh dear.
How long can you hold your breath?
So I know the
well,
average. Are
No,
you asking
Rachel.
us specific?
You.
Okay.
Yeah.
Am I underwater?
Sure.
Like maybe about like 2-ish minutes.
Ooh.
One
all
and a
right.
half,
I don't know.
2 minutes.
I could probably hold it for a minute, but I wouldn't like it.
Yeah, I'd say the average kind of, you're right, kind of on track there. The average person can fairly easily reach the 1 minute mark. That's I know I can do a little over 1 minute. It's not
Mm-hmm.
all that difficult. Pearl divers famously can hold their breath longer than most other
Mhm.
people.
Mhm.
They can double that 1 minute to a whopping 2 minutes is how long most of those free divers are down there. There
Mhm.
are definitely people who can go longer. You tend to hear about
yeah.
the people who have much longer, but
Yeah.
I looked it up, and the average people free dive for pearls, it's like 2 minutes. So
There are
it's
those-
still a long time.
Crazy competitive free divers who hold for 6
There
or 7
are.
minutes or
That-
something.
yeah,
Indeed.
like 10 minutes. I heard.
Well, I did some digging on this too, because as you say, humans have turned this into a sport
Mhm.
with like federations and events and even doping scandals.
Wild.
It's wild. Generally, the record confirmed with no doping or extra oxygen is currently thought to be a little over 11 minutes,
Whoa.
Mhm.
which is a very long time.
That's so long.
By breathing pure oxygen first and kind of really super saturating your blood, one person did manage to get to 29 minutes underwater with no breathing.
Whoa.
That's
That's wild.
terrible.
Yeah, sounds pretty awful.
I mean, it's one
Yeah,
of the
that
most
sounds
dangerous
great.
sports in the world.
yeah, it's
Yeah.
not, that's why they have a lot of these like, federations and like organizations trying to make sure people are doing it as safely as possible.
Mhm.
So that's all very impressive, but it isn't exactly what I'm talking about this week.
No, because when you first brought this up, Kirk, like my immediate thought of like when we teach survival to kids, it's like, okay, how long
Yeah.
can you go without oxygen? Like on
3
average,
minutes.
it's like 3 minutes
Yeah. Yeah.
before brain issues start to
Bad
happen.
things happen.
And that's
Yeah.
why, there's divers who do special things to increase their blood oxygen level before they will
Yeah.
go in,
Mhm.
whether it's breathing oxygen or sort of hyperventilating and things like that. But
Mhm.
that's not really what I'm talking about here today. Today's story for sure has to do with holding your breath underwater, but not for humans.
Okay.
So we often
Okay.
think of a lot of animals that hold their breath underwater But when I say, and you can think of all kinds of whales and beavers
Muskrats.
and all kinds of animals. But when I say like underwater, you're probably thinking about a lake, a river, the sea, the ocean, essentially like a body of water is
Not
usually
like a
involved,
puddle.
right? Yeah, not like a puddle. But there is another place that you might need to hold your breath, and that is in your home. Which sounds strange, right?
Kirk,
I want you to imagine
don't
that you woke
don't
up.
make me afraid of my house anymore.
Well, think about your house here, Rachel. You wake up to discover that your house is flooding and rapidly filling with water. This is pretty much a nightmare scenario. I've
Multiple reasons.
I've been there in that
it-
situation.
Oh,
Is
when
it
I
my
was
current house?
when I was in fifth
Oof.
grade, our house was flooded with 8.5 feet of water
oh my gosh.
in a matter of hours.
That's right.
It was unpleasant to say the least.
Mhm.
And when my childhood home flooded, we could just move to a higher floor to escape the waters. It wasn't like a single level home. So it was the basement
Right.
that flooded essentially. But what if your whole house is underground?
Oh.
Nope.
If you
I'm
are
out.
an animal that lives underground in a tunnel,
Yeah.
Are
there's
you
a
talking
very
about
good
ants?
chance that it could flood. No,
Are you talking
not
about
ants. Not
Ooh.
ants.
Okay.
Now, sure, you could move to a higher part of a den, or simply leave your home, like ants could. If it started to rain or something, you go to that higher ground. But what if you are hibernating, brumating, or in some way still overwintering when this happens?
Mm.
So
Huh.
many animals seek shelter underground in the winter, where they're kept far away from, the winter snows and winds and cold and whatnot. But
Right.
famously, all that winter snow, it melts. Right.
Yeah.
So
And
what
you get
happens?
The spring thaw.
Yeah, that spring thaw, all that melting snow turns into water and then floods your subterranean home. What if that happens before you wake up? Pretty
I'm
tricky,
real
right?
sad.
Yeah. So this is a real problem that animals
Hopefully
have to do
my
with.
fur is floaty enough. I have fur and I'm floating.
Well, in this case, you don't. Well, you don't have fur, but you're maybe a little bit hairy.
Are you a bumblebee?
You are a bumblebee, yes.
Ooh.
And so
Okay.
bumblebees have sort of long interested researchers. And specifically, we're talking about bumblebee queens. So
Mhm.
bumblebees, most of them die off when winter comes, and only the queen survives winter. So queens will burrow underground and they go dormant, or something we call diapause, where they wait until spring when they can lay eggs and then rebuild the whole population. But this
Mhm.
poses a problem. Bumblebees seem to emerge after the snow has melted. So what happens if we get a very heavy snow melt that floods their homes? Like, do they die? How long can a bumblebee hold their breath? Is essentially the
Yeah.
question that people wanted to know. Well, we finally have an answer, and it's pretty cool.
Ooh, I love this. Also,
Yes.
I'm just gonna say, just flat out, this episode feels like just like the cutest little love letter to me and my favorite topics. I'm just sitting here, I'm like, oh, this makes me so happy. I like both of these things.
Well, next week I've got something for Victoria.
Oh, good.
I have something for Victoria.
Oh, that's
this
going to be
gross?
amazing. Sure is. All right, but this isn't gross. So, postdoctoral researchers, Sabrina Rondow, did research on this question and discovered that queen bumblebees have even beaten the best humans in the breath holding department. So she showed that a queen bumblebee can survive for at least 8 days underwater.
What?
Yeah,
Wow.
and this is pretty amazing research, but like all good research, it spawns even more questions.
I have so many questions.
Right. And a big one was simply like, how?
Mhm.
How can an oxygen breathing animal spend 8 days underwater? So they did a bunch of studies to figure out like really what's going on. So I think it was previously maybe known that they could be underwater, but this was to study like not just how long can they be underwater, but how are they doing it? And here's what this team learned. The first isn't too surprising. The bees are still in diapause, which means that their metabolic rate is extremely low. And this is actually the reason that there are anti-doping rules in human competitive breath holding, because apparently athletes have been caught taking beta blockers and other drugs that essentially slow down metabolism. So if you don't have a high demand for oxygen, then you can go longer without needing it. And in their dormant state, bumblebees don't need a huge amount of oxygen. But I should point out, they are still alive and they do still need oxygen, even when they're in diapause.
Yes.
So one of the interesting findings was that even underwater, there was still an exchange of gases going on.
Oh.
So basically, the bees were somehow able to get a small amount of oxygen directly from the water.
Huh.
Kind of like how turtles can breathe through their butts.
Probably.
That's
the paper
what I thought
that I
about,
read
too.
did not directly go into that, but I'm assuming this is like a direct gaseous transfer through the skin. So that is very cool.
That is so cool.
Wow.
Looking into it further, they also detected a buildup of lactic acid in the bees.
Yeah.
And this is a pretty interesting finding. So we need to think for a minute about something most humans never think about. Why do we breathe? Right? It's like, well, a lot of people don't even think about that question. Well, one reason or one possible answer is, well, because we need oxygen.
Right.
Okay, true enough. So why do we need oxygen? Right?
For cellular respiration.
Yes, for respiration.
Yeah.
So oxygen is the key component, one of the key components really in our metabolism. It is what allows us to strip energy from nutrients. And the process is basically us playing the Uno reverse card on photosynthesis. Right? So in photosynthesis, the energy from the sun is used to bond carbon dioxide and water together to form sugar. And oxygen is the garbage byproduct of that reaction. Our bodies can use that byproduct, oxygen, to reverse the process and split the sugars back into water and carbon dioxide. We breathe out CO2 and we urinate out the water, and we're left with the energy, which is essentially from the sun, which is amazing that we technically are solar powered.
Yeah.
So that energy is what keeps every part of us alive. And we constantly need oxygen to keep respiration going and to keep the energy flowing. And turns out, though, there is another way to get that energy. It isn't very efficient, but some organisms, including humans, can use anaerobic respiration. They can break down food into energy without oxygen, and it's through a process called lactic acid fermentation. And if you've ever had like really sore muscles after going for a jog, then you yourself have done this. When we're pushing our bodies hard, like say in a race, and we aren't getting enough oxygen to our muscles fast enough, but still putting great demands on them, they start to use this backup method to get extra energy. And the problem is that lactic acid builds up in the muscles, and as a result of that buildup, it can cause our muscles to feel sore for a few days while our bodies work to get rid of that lactic acid. And when researchers studied the bumblebees, they found a buildup of lactic acid, which indicated that they too can use lactic acid fermentation to get energy they need while they are completely submerged underwater for over a week, which is
that wild.
Awesome. So just like your sore muscles, the bees do have to recover as well. So once the water recedes, keep in mind they're still in diapause, but they actually increase their metabolic activity while still in diapause so they can purge their systems of the lactic acid before going back into a deeper diapause to wait for the actual temperatures to rise enough for them to emerge. And then they lay eggs and start the whole process all over again. So next time you're holding your breath or rubbing sore muscles after a race, think about our amazing bumblebees and their ability to hold their breath for 8 days every spring.
Oh my goodness.
That's
so cool.
So cool.
So my sources for this was, I used Wikipedia for the records on breath holding. It's a pretty interesting article, actually. And then Earth Sky Magazine, who also covered this research. The actual journal article about this study came out just a month ago in the Proceedings of the Royal Society Bee. If you want to check that out, that's the letter B, not the animal bee, but pretty funny. But that's what I had for you this week. Breath holding bumblebees.
Oh, so cool.
Well, you can think about that while we take a little break, and we'll be back with Rachel. This week's episode is brought to you by the Society of Strange. That's what we call our patrons over at patreon.com/strangebynature. Society members directly support the show they love, and depending on their level of support, get fun perks such as bonus content on select shows, insider photos, water bottle stickers, and here's a big one, every level of support gets every episode 100% ad-free. Come join the other lovers of the show, help keep this strange show going, and get those ad-free episodes. We'll see you all over at patreon.com/strangebynature.
Welcome back to the show, everyone. So I mentioned that, I did mention both Kirk and Victoria, you both chose topics that I really love. Like, I'm just sitting here like, oh, these are so great. Like my favorites. But I started something last week and I gotta finish this out. So it's kind of a Victoria-esque episode here because I gotta talk about...
Last week on the... What do you remember what you talked about last week?
Oh.
Week before last?
It would have been a while for us while we were recording. So last week I talked about the autoappendectomy that happened in Antarctica.
Oh, how could I forget? Oh, man. I think I blocked it out. That's what
you
it
did.
was.
You did. You didn't like that.
No, I did not.
And, I was talking about the autoappendectomy, but I never got into the appendix itself.
Oh,
which
sure.
Oh, right.
In it of itself is
We could have included it in like
pretty
an appendix, the appendices of the show or something.
Right, exactly. Terrible.
I'd like to take a moment to apologize to our audience for that. The joke
You
that
apologize for nothing.
You deserve better. And it was a cheap joke. I saw the opportunity. I took it. I didn't feel good about it, and I apologize. Go
on. So I wanted to talk a bit about the appendix. So the appendix itself, for those of you who don't know, it's this little tiny organ that is attached to your colon, and it is. When I say it's tiny, it's very small. And it's just a tube little organ, and it actually has different ways that it can sit within the human body, which I didn't know and is actually kind of horrifying to find out.
Why is it horrifying?
Well, I just don't like when things are not where we think that they should be, and the fact that it can be in multiple places bothers me slightly. Because in my head, like,
and there's some topics we could talk about on this show that are really going to bother you.
Yeah, that's very fair. I think the main part of it is the fact that it, like, in my head, having gone through anatomy, and I realize, okay, people are going to at me about this. I understand that the human body is not the same as in the textbooks, and that it's our best, like, representation
It's an average.
of...
It's much slimier.
Of an average, and it's much slimier, and organs are never exactly where you think they are going to be. I understand this, but to like visually see that in a diagram that your appendix can be in like 6 different like orientations, especially since this organ, as we discussed last week, can be so problematic.
Can kill you, yeah.
Can kill you fairly easily. I did not like that.
Okay. Fair enough.
All right. So let's talk about it. So the first ever successful appendectomy was actually in 1735. So it's been a problem for a very long time.
Wow. There was no anesthetic for that one.
No. Also, it was done for an 11-year-old boy.
Oh, gosh.
That's so
Yeah. Well, he swallowed a pin and it perforated the appendix. So yeah. All right. So I'm glad that we got that out of the way. So the yeah. Okay. So the appendix
Why did we let her go last?
Generally seems to be a useless organ. That's generally what people seem to think when it comes to the appendix.
Yeah.
Like, why do we still have this organ? It's known, like, even Darwin thought it was just this vestigial thing that carried over from when we ate plants more, which, but here's the thing, is it seems like the appendix actually has a pretty interesting history. Not only does the appendix seemingly occur in a case of convergent evolution among 3 different mammalian lines, so it occurred on its own 3 different times with mammals.
Oh, okay.
Interesting.
Huh.
Which is, and when you look into more about that also means that it seems to have evolved somewhere around independently, like 32 times is the number.
What?
Wow.
Yeah.
Fascinating.
So there was a broad
so then
evolutionary survey.
It must have a use then.
Exactly. So it evolved separately at least 32 times among 360 mammal species, I should say.
Yeah.
Okay?
Huh.
Right. So you would still think, yes, must have a use. We're mostly sure what it does.
Mostly sure.
Mostly sure. Because as in the last few decades, even the last century, public health has gotten a lot better for humans overall. I don't know if we've talked about it on the podcast much at all, but the fact that clean water has mostly become...
it's a big one.
Clean water has become more accessible to more people.
Yeah. Healthcare
has mostly become more accessible to people, as well as sanitation and things of that nature has become more widely accessible to people. That means that diseases that rely on not as clean water or issues with sanitation have gone down within the human race.
Right.
Okay? Mm-hmm. So, what does this have to do with the appendix? The appendix, it seems, has something to do with our immune system. It's been thought to not only produce certain help with white blood cell counts and things, but it also seems to hold, it might be like a refuge for gut microbes.
Yeah, that was the one that I had heard.
That's what I've heard.
Yeah, so scientists think that it could hold some like gut associated like microbes as like a little like just in case something happens within your colon that just takes out all your microbes that help break down everything.
Gee, Rachel, what would that be?
Get a nice dose of cholera or something.
There you go.
Exactly. Cholera, diarrhea, just oof. Well, this helps get the what a tragic day. But it actually helps like replenish your gut biome. So it was more useful in the past in that way. It also seems to be really helpful for early life when it comes to immune systems.
Oh, interesting.
Especially when our immune system is actually still maturing, so through childhood and adolescence. So it seems like the appendix becomes more useless when you're an adult, which is really helpful. So they have like it participates in mucosal immunity, so it helps regulate the microbial populations and such, but it also helps produce antibodies like such as immune globulin.
Immunoglobulin?
Yes. Immune. I found a new one.
Immunoglobulin.
Why can't I say this today?
Say immune.
Immunoglobulin A.
But with an O.
Yeah. immunoglobulin A.
Just
Oh my god.
so Rachel, say immune.
Yes.
Say O.
Immunoglobulin
There you
A.
go.
Yes.
I looked at that word. I'm like, yeah, I got it. That's fine. God. So that's a type of antibody that the body uses when you are sick to help like carry on tasks and like help you get healthier. So it does have a purpose, and like it has been helpful in the past, and it just seems to not be as helpful now. So when people are like, well, it has to be like dumb. It doesn't, it's not this spare part or whatever it might be, this vestigial little organ. I mean, maybe now, but
it could be both, right?
Yeah. Like it clearly had some sort of like pressure that like we talked about. It had an evolutionary pressure to be part of our system because it evolved so many separate times. Like that doesn't happen very often, especially in mammals. Like you have to have the right preference. Yeah. So even though like this little organ, which is upsettingly in like 5 or 6 different spots within your body.
Now, when you say that, Rachel, I Googled it. Like, so it comes out of the same
still
spot.
Attached.
But
yeah,
it's
but
not
it's like
could be in your shin, could be in your eye, your ear.
No, it's just laying in different places.
It's always in the spot where the large intestine comes out of the small intestine.
Yes, it's always
but
there.
It can be facing different directions or like pointing different directions.
And I don't like that.
Well, Rachel, your head can face different directions. Do you like that?
How sore is my neck?
Well, none because you have 7 cervical vertebrae that allow it to move around.
That's true. I don't know. It just vaguely bothers me, and
fair enough.
I think also what is really bothering me is the diagram where I'm seeing this is actually, I don't like how they have it laid out. It's not appealing.
Okay.
Yeah.
Okay. Anyway, so the appendix, as it turns out, is not actually that useless. It's just this little ongoing tiny organ that sometimes causes problems, and I just wanted to clarify a little bit about this little tiny organ that I did not end up having a problem with.
Well, very
fun. There we go. And also it's just wild that it was evolved into so many different times, because that doesn't happen often. So it had some use.
Very cool.
So my sources this week. So there was a great article about the history of the appendix in Live Science, but also there was the story of the appendix in the National Library of Medicine, the story of the appendix. That was originally written in Czech, so I am not going to attempt to say the name. Actually, no, I will. Karel Lucas. Okay.
Oh, that's pretty easy.
Was not as bad as I thought it was. I'm like,
Okay.
I saw that it was written in Czech and I got nervous. There was also Columbia Surgery had a great article about the history of medicine, the mysterious appendix. And then I got some background info from Wikipedia.
Fantastic.
And I think that brings us to the end of the show.
Wonderful.
Hey.
We did it!
Yay!
All right. Well, that is it, everyone. We will see you all next week.
Bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all our listeners. If you would be so kind as to leave us a 5-star rating and review wherever you get your podcasts, that would be great. It lets other lovers of the strange discover the show. You can reach us by searching for Strange by Nature Podcast on Instagram, Facebook, and Blue Sky. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can check out our website, strangebynaturepodcast.com, and you can support the show and get ad-free episodes at patreon.com/strangebynature. Until next week, get outside, stay curious, and embrace the strange.